In the figure, AC intersect BD at point E. As you can see in the figure, AE equals 8, BE equals 4, CE equals 6, and DE equals 12. Prove that A, B, C, D are concyclic. The meaning of the word concyclic, that is, a single circle passing through all these 4 points. As we know, if you are given 3 points, they are not on the same straight line, you can use a unique circle, only circle, to pass through these 3 points. But it may not guarantee that when 4 points they are not collinear, you can also use a single circle to pass through all these 4 points. It works on 3 points they are not on the same straight line, but it does not sure when there are 4 points on the same straight line. So if you need to prove that all these 4 points are actually lying on a single circle, you need to satisfy some condition. Basically, there are 3 conditions. If you satisfy either one of them, then you can say these 4 points A, B, C, D are concyclic. The first one is, if you find that if x equals y, then you can conclude that A, B, C, D are concyclic. The reference is converse of angles in the same segment. Second, if you find that in a quadrilateral ABCD, if the sum of the opposite angle equals to 180 degrees, then you can also conclude that these 4 points are concyclic. The third one actually quite similar to the second one. If one of the interior angle in the quadrilateral equals to the exterior angle of its opposite angle, so you can conclude that A, B, C, D are also concyclic. But the problem is, which reason we need to apply? Just go back to the question. As you can see, A, B, C, D is just like the shape of bow tie, or you can say the shape of butterfly. So among those 3 conditions, only the first one will be satisfied. That means you want to prove either angle A equals angle D, or angle B equals angle C. So how do we prove that? We may try to use these numbers. Think about it. Can you observe any relationship between these 2 triangles? What can you think about 8 to 6, 4, 12? If you cannot think of this relationship among those numbers, try another pair. How about 8 and 4, 12 and 6? Yes, you can find that when you consider triangle ABE, there are 2 lengths 8, 4. The length ratio 1 to 2. In another triangle ECD, the length 6 and 12, also with the ratio 1 to 2. So you may think these 2 triangles may be similar. So let's check it out. In triangle EAB and triangle EDC, now why not ECD but EDC? Because you want angle A match with angle D, so you need to follow the order. Now we can check the length of EA to the length of ED. What is the ratio? That is x over 12, 2 to 3. Similarly, we can check another pair, that is EB. When you look at the position of the letters, there's 1, 3. So in another triangle, you also look at the letters with the order 1, 3. That's EC. So EB over EC, that is 4 over 6, also equals to 2 over 3. That means the length ratio of two pairs of triangles are the same. Also, angle AE boy equals to angle dot EC. Quite straightforward because that is a vertically opposite angles. So you can make the conclusion. That is, these two triangles are actually similar. And the reason is ratio of two sides. That means the two pair of the sides of the triangles are in the same ratio. Also, their included angles are the same. You get this conclusion now. That means angle EA boy equals angle EDC, that is corresponding angles of similar triangles. Because you proved that these two triangles are similar, that means their corresponding angles are equal. But you can also see that since angle A equals angle D, by the condition we check here, when you see the butterfly shape and these two angles are the same, then you can make the conclusion is these 4 points are in the same are concyclic. Therefore, you can make the conclusion A, B, C, D are concyclic. Reason: converse of angles in the same segment. That's finished the question.